Ladies and gentlemen, hello and welcome back once again to the Inside Analysis Big Data Ecosystem Market Overview. We're pleased today to have Tom Fountain of Neuron, and he's going to talk about their technology fits into the big data ecosystem. Tom, the floor is yours.
Thank you very much. Today we're going to demonstrate two key web applications from the Neuron platform. First, we'll talk about the Design Studio, where solution designers design, deploy, run, and maintain targeted business solutions in the form of distributed processing networks. And in a few moments, we'll talk about the Neuron Dashboard, a second web application where both end users and designers can visualize intermediate and final processing results. Within the Design Studio, we operate within an area called the canvas, where individual solution designers can select, configure, and integrate different neurons to create distributed processing networks to solve these targeted business problems. We have a library of over 50 different neurons that are organized into different libraries, including analytics, where we have embedded a vast majority of the available open source from the Apache Math Library to advanced matching algorithms and other predictive model capabilities to provide a rich analytical environment, and our data interaction library, where we have a host of neurons that provide easy and rapid access to the wide variety of underlying systems within your environment. For example, we can pull specific files that contain targeted content from directories. We can parse that content from various flat files. We can interact with FTP and websites. And of course, we can pull data from targeted relational databases with our query neuron. As we work through the Design Studio, we'll highlight a number of actions and capabilities that allow you to customize your environment and to productively deliver these applications in a very rapid and innovative way. One of the key capabilities within the Design Studio is our Alias Management concept. Aliases are used to create credentialed connections to underlying sources in your environment. We have a wide range of aliases, including data sources, websites, FTP sites, and other connections that allow you to control access and grant permissions to individual designers for their use. One example is our data source alias, which connects to a wide variety of relational databases, as you see in the drop-down list. This allows the database administrator to configure connections and then permission those connections to select individuals or groups of designers for their use when building targeted solutions. On the screen, we see the first half of one of our particular use cases, which is the FATCA use case. FATCA is an IRS regulation that requires banks to understand their customers and all of their accounts on a global basis. This is typically a difficult challenge because of the onboarding processes in different geographies can represent customers in very different ways. And through the process of gathering data and then performing matching and other types of analysis, we hope to create a single gold copy which represents all bank customers and their individual accounts. I'll walk through a couple of different neurons to give you a sense of how these are selected and configured and how by stringing together you can create a distributed instruction chain which will solve this particular problem. One example is our schedule neuron. And as I open up the properties of the schedule neuron, you can see a rich capability to devise specific processing schedules based on days, excluding holidays, recurring times, and recurring intervals to allow you to have complete control over a scheduled execution of this given network. You also have two other ways to execute individual networks. First, you can simply select from the menu the fire button, which will execute that neuron on an ad hoc basis, or because we have web service enabled all individual neurons, you can control the execution of the network from external applications. Our query neuron is a very commonly used neuron, and as I open up the properties, we can see a variety of properties that will control its individual behavior. Very importantly, with a single drop-down, you can position this neuron to be executed on any installed neuron server, regardless of where it is located in your environment. Although I only have one server installed here, if you had a selection, you could pick and simply click to position the processing for that neuron, typically proximate to the data source you're working with, to localize processing and reduce the bandwidth for transferring any information across your network. A second important property is the source. The source is drawn from the list of aliases that you as a solution designer have been permissioned to use. Here I'm picking information from the retail accounts in the UK, which will allow me to select targeted information from that specific database in furtherance of solving my business problem. A final important property is the query itself. Here I'll open up our visual query builder, which allows a novice user a visual way to select specific tables and fields within that table for use within a query. As those fields are selected, they're added dynamically to our grid, and from there aliases, sorts, and other criteria can be added with the resulting SQL statement being dynamically generated to allow a fast and efficient specification for the data that you wish to retrieve. Upon receipt of an incoming message, this particular neuron will execute that query, package up the results of that query into a self-describing XML message, which is then passed downstream to one or more subsequent neurons in this distributed processing network. As we've collected data in this example, that is then sequenced into this second phase of the network where we're performing various analyses, and we'll open up a matching neuron. This is a very different type of neuron and has a single property, but within that property you have a complete ability to specify a very complex processing chain which will execute a set of instructions. That could be declaring local variables, setting those variables, and firing other portions of your network. Within the set statement, we can see a formula editor which gives you further control over the selection of specific algorithms and the use of specific inputs that have come from prior neurons to be used within that processing step. We have a powerful capability to add additional functionality as you may have already developed intellectual property that you wish to reuse. Here we've already embedded dozens of high-end matching algorithms that you could replace in contrast to the original Level 2 Gero application being used as an address matching algorithm. You could select with one click various algorithms and experiment very rapidly to fine-tune the processing cycle. As we move further down the network, when we arrive at a valuable intermediate result, you have the option to persist that result. It's important to note that Neuron alone does not decide for you where, when, or how to persist results. As the designer, you have complete control over that operation, and in this particular network, this intermediate result, that is the customers and their specific accounts matched to that customer, has been persisted. That is then used by multiple other projects. In this top path, the remaining steps of the factor analysis are performed, but in other cases, customer analytics, client propensity can all be run from that same intermediate data source. As we shift over, we can expand this subnetwork to give a view of a secondary product that has been built off of that gold copy database. Here I'm retrieving those results and I'm passing it first to one of our service neurons. A service neuron allows you to call web services and APIs that have been exposed within your environment or are available outside of your environment. As I open up the detail, I can look at the specific alias and I see the WSDL statement, which is shorthand for the language explaining how the web services are being offered, in this case by Dun & Bradstreet. As I examine the available methods within that service, I can see a very rich set of services that are offered by Dun & Bradstreet, and I can simply choose from this list. In this case, I've pursued getting company market data, and if I found it necessary, I could map parameters that are incoming from prior messages in the network, and I could map those to the specific arguments that are required for a chosen method. This gives you complete control over specifying the arguments that need to be used to call each of the individual services that Dun & Bradstreet offers. This is a great method to augment or enrich your internal record set with additional information from other sources. A second step in this product is to now perform customer segmentation analysis. This is a SAS neuron, which is a specially licensed neuron that gives you the ability to import previously built SAS models and create an executable within the environment. Here I will import a specific SAS model in the form of a zip file, and within just a few seconds I will convert that exported SAS model into a neuron executable that is embedded within this specific neuron. That's now been created, and it is available for processing as results come through the network They will run against this particular service segmentation model and perform further analysis that can then pass to my follow-on neuron, where the results will be published or can be distributed to any number of other sources. We also have a number of other important neurons I will just mention. One is called a wrapper neuron. That allows you to import existing Java files in a similar fashion to what we just experienced to reuse existing applications and proven intellectual property, but have it in the same deployment model and the ability to distribute that processing within the neuron environment. And finally, we have a custom neuron. A custom neuron allows for creation of entirely new neurons where an individual customer may have specific intellectual property or other behaviors that they wish to import and create their own specific dedicated neuron. That provides a great flexible model to incorporate additional functionality that may be unique to a client that Neuron has not built into its standard overall library. I'll shift now to a separate network example. This comes from a pharmaceutical example where a manufacturer wants increased visibility into its supply chain. In managing clinical trials, it's critical to have inventory properly placed across distributors and clinics, and this particular network is giving us increased visibility to the actual performance and stock levels at different distributors and clinics. A few important facets of this network include the combination of start and check transactions. The start transaction will initiate this series of parallel data aggregation activities, which is accumulating data from databases, Excel spreadsheets, and CSV flat files. A particularly relevant example, given that these distributors and clinics are not owned by the drug manufacturer, and at times there's a negotiation of what type of data and the availability of that data can be offered back to the manufacturer. Neuron has a very rich set of ways to import that data and aggregate it for further analytical purposes. The start and check transaction ensures that all of the data aggregation steps have been completed prior to kicking off these subsequent analysis activities, making sure that all data has been arrived and placed in a proper position to then be analyzed in a more comprehensive manner. Shift over to a view of our dashboards. Here I've got, from the same supply chain example, a distributor dashboard. I have several examples of different types of widgets that are offered within the Neuron platform, including stacked bars showing the inventory by drug, by date. I have total inventory transfers across a time period, where I can assess shipments that come from the manufacturer or out to clinics. I have a view of the balance of stock transfers between different distributors. This is very insightful for the manufacturer to understand that stocking levels may not be optimal between different distributors, and there is a high degree of required transfers laterally between different distributors. In this heat map, I have a view of the returns trend over time, where numbers of units may have to be returned back to the manufacturer. So green indicating no returns is a success, but 4 or more returns would signify red, giving me an indication that perhaps quality or timeliness issues were present on a particular day. I have the ability to view rejection rates on a day-by-day basis across the different drug types, see how, whether on a daily basis or over time, I have a high degree of returns that need to be investigated. Finally, I have a radial gauge, which is giving me a view of total aggregate inventory at the specific distributor, and if it's within 10% of the target, I'm signifying as green, above that, yellow, and if I'm exceeding my targeted by more than 30%, I'm indicating a red range that will give me a cause to go investigate why there may be particular issues within my distribution process. One additional dashboard that I'll also highlight is from a financial services example, where risk management is a prime concern, particularly on a global basis. Here, we've implemented a scoring model, which is assessing the levels of risk based on industry, based on type of business, based on geography, and a few other factors. And we're providing a variety of visualizations of the breakdown of high, medium, and low customers, the distribution of scores, the geographic distribution of high-risk customers. This is particularly useful if I need to optimize my staffing by region to ensure that I have the right attention on the highest risk regions. Here I have another heat map, which is indicating the number of high, medium, and low customers based on my top 10 market areas. And I can always display in normal tabular form full details about individual customers and the components of the risk model scoring. So in conclusion, overall, Neuron is very focused on driving high developer productivity and a rapid ability to convert innovative ideas into working solutions. By non-invasively connecting to underlying sources, we can gain real-time access to key parameters and perform analyses that will provide insight that is both actionable, and because of the integration ability with applications, we can help convert new insights generated by big data and inject those directly into run-the-business applications to help close the loop and create and realize the value potential from the additional insight generated by the big data and analytics that are popular today. Thank you, and please visit www.neuron.com for more information, and we'd be happy to provide demonstrations and further information. Thank you.
Great, thanks, Tom. And I've just got a quick question kind of in regards to big data. And I understand that, you know, with your distributed processing, it probably doesn't matter how much data you are going after, does it? Or is there a bottleneck or a limit or some benchmarks you've come up against?
Yeah, it's a great question, and you're right. The distributed nature of our processing provides great scalability. So a feature that is hard to visualize, but I'll explain, is our cortex, which is really the core component of our intellectual property. The cortex manages all performance and resiliency aspects of the platform. And by installing multiple cortices, plural, you can distribute processing across that range of hosts by dispatching units of work across those multiple worker nodes. We also have the ability to dynamically scale into your cloud or grid environment in a dynamic fashion to deal with escalating workloads and dynamically release those pay-per-use options when the workload is back to more normal levels. So we can rapidly scale, and through that clustering, we can give you the high availability and resiliency that you require for mission-critical applications as well.
So I can see the smartness of this product in terms of its distributed capability, especially for doing stuff in the cloud. But let's imagine that you know, I have a situation where I've kind of managed to tame Hadoop, and I've got a data warehouse sitting next to Hadoop, and I've got a nice flow of data going from Hadoop to the data warehouse. And that's mostly the kind of thing that I would be pulling BI out of. Would that be a context in which I might use this product anyway?
Absolutely. The real value point, or one of the key value points for Neuron, is the ability to rapidly connect to a wide range of sources and bring those together into an interoperable environment. In many cases, the value that's being created out of either big data or, frankly, conventional data warehouses is only fully realized when you combine it with other planning applications or execution applications. So within the Neuron environment, with our different integration tools, you can connect to those run-the-business applications or planning applications and use the insight that's being extracted from either the big data or conventional data warehouse environments and integrate that in a very rapid, innovative model to say, how can I best optimize the use of that information to actually create actionable intelligence that is then used to run the business in a smarter, faster way. And the ability to experiment very rapidly without recreating ETL and the numbers of other conventional prerequisites allows you to very quickly optimize that combination of systems and analyses to generate value.
Okay, so and I mean it's true because I've been briefed by you that I know the difference, but I think it might be a neat idea if you explain the difference. The way that you just described that sounds like it could be like an enterprise service bus, you know, clip it onto the data at the back and go and feed some applications up front. So could you explain how Neuron is different than that?
Sure. There are certainly parallels, and in many cases we think of the cortex as a distributed service bus, if you will. Each individual neuron is a configurable application that allows you to connect to not just data sources, but applications, websites, and so forth. So our ability to incorporate natively the actual processing, the logic, and connect those in a fully interoperable environment without the prerequisites of the infrastructures and training and development that is typically required in SOA can significantly shorten the time period and the cost and the risk of building these solutions in a very iterative fashion. Certainly, as you get through those design cycles, you can begin to optimize different portions of the solution, in many cases just by changing out different neurons but maintaining the end-to-end integrity. So it's really the flexibility and the agility and the sidestepping of the conventional prerequisites where we really set ourselves apart from some of the more classic SOA approaches.
Right, and in the case of having an ESB, I would have to go and buy myself a server, possibly even a bulky server. In terms of running Neuron, would I actually have to buy any specific hardware to deploy?
No, actually not. Our Cortex is a very lightweight runtime server that is optimized to only consume resource when work is being performed. Typically, we run very successfully within the available capacity of existing physical or virtual servers. So you can deploy a Cortex and then optimize, as I showed in the demo, where you can position different neurons to run on different hosts within your environment to, in effect, decide the topology of processing to take full advantage of what you have in different regions and different servers and so forth to best align processing with the available capacity. You can certainly buy dedicated hardware, but it's definitely not needed per se to give you that type of processing throughput. We're naturally taking advantage of the distribution of the availability, frankly, of the processing you may have in your environment. So rather than having to buy a dedicated server, we could use the 15 or 20% of 5 or 6 different servers to effectively accomplish the same amount of work.
Right.
Well, great. Robin, did you have any other questions? Mary Jo?
No, I think I'm done.
No? Okay. Well, this has been another great demo for our Big Data Ecosystem Market Overview. Thanks so much, Tom Fountain from Neuron.
Thank you very much.